up till now, in order to persist our data, we've essentially only been using single tables, right? If you think about how we save data using user defaults or using our plist and the Codable protocol, we were still saving things into a single table that had a key value pair. Now, this is equivalent to your tables inside Excel, for example. So in order to explain the next step of persistent data storage solutions, let's use an example. Let's say that you own a small bakery, right? And in order to keep track of your orders, your ingredients, your cost, you have to make a table, right? People would probably do this normally inside Excel. And inside this single table, you list all the things that you can make. So you just make cookies, brownies, and cakes. And you have columns where you can write down what are the ingredients, what's the cost for each of these products, and how many orders you're getting, say, every month or every week. And this can be easily done using our plists or using our user defaults. But what happens if, say your cookies get featured on the Cookie magazine, right? And you end up being the best chewy chocolate chip cookies in the world. What are you going to do? Well, then your sales are going to massively explode and people are going to be queuing around the block to buy your cookies, right? Now, I just want to take a moment and pause and reflect on the fact that it took me about half an hour to find the perfect cookie image to illustrate this slide. And given the fact that I've been trying to cut all sugars in my diet for the last year, I just want you to know how much of a sacrifice I've just made for you guys looking at a million chocolate chip cookie images that I can't have. But anyways, let's continue. So your business explodes and you now have loads and loads of orders, including big supermarkets and big brands, and they all want to buy your cookies and all of your bakery goods. So your single table inside Excel is not going to cut it anymore because you now need to keep track of a lot more things. So for your products, for example, you need to be able to track the ingredients, the cost, the shelf life of each of them, what are the nutrition details, because all of these big shops, they all want to know, right? So you have to test that and you have to update the products table. But in addition, you might want to keep track of your buyers, right? Say Walmart, Tesco, and Whole Foods, they're all regular buyers of your stuff. And now you need to know what is their address, what are their phone number, what are their bank details, who do you need to contact in order to invoice them, a whole bunch of details about your buyers. So you need another table. And then in addition to your products and your buyers table, you also need to keep track of your orders, right? So for example, this month, Walmart wanted 2 batches of cookies, Tesco's wanted 12 batches, and Whole Foods wanted 10 batches of your brownies. So you need to match up the items from the products table to the buyers table in order to know who to invoice, who to send which details about which products, a whole bunch of data. And you now have 3 tables. And the tables are related to each other. They have relationships, right? They're not just single tables. Because when you have an order for 2 batches of cookies to Walmart, you need to pull out data from the products table for the cookies, and you need to pull out data from the buyers table for Walmart. So you now need to establish relationships between the tables. And this is when you will need a database. And in the coming lessons, we're going to be talking about 2 database solutions that are way more sophisticated than the single tables that we've been working with using plists and user defaults. And they'll allow us to establish relationships between our tables or between our classes so that we can perform far more complex tasks like querying our database to find a particular item or linking 2 tables together using relationships. Now, let's just quickly review some of the methods that we've come across to persistently store our data on the local device. So the ones that we've seen and that we've used are user defaults and Codable. So the first section here, the ones in blue, are essentially tables. They're plists or they're individual tables that tracks a small amount of data. Now the 3 solutions in yellow are databases or database solutions, and they allow for more complex data and apps with more complex needs in terms of data storage and data retrieval. So let's go from the top. So the first method that we saw and we used in order to persist our data, which is probably the easiest way of doing it, is user defaults. And this allows you to quickly persist small bits of data, things like what is the top score of the user, what is the player's chosen nickname, or whether if you want music on or off. These are really small bits of data, and that's what you should use user defaults for. Once you start trying to put objects into user defaults, then you know that you're probably doing something a little bit wrong. Now, that's when we moved on to the Codable protocol, which allows us to save many individual plists that contain our custom objects. So you can see it almost as taking an ice cream and dehydrating and storing it as astronaut ice cream, which tastes terrible, by the way. I don't know who came up with this. But it's a good analogy for the item saved with the Codable protocol. You're basically flash freezing your custom objects into a plist, and then when you use it, you have to retrieve the entire plist or load the entire plist into memory before you can use any of the items or objects contained within the plist. So again, it's memory intensive to load up an entire table when you only want one or two items inside it. And this is why the Codable protocol, saving your custom plist to file, again, should only be used for small pieces of data, so less than 100 kilobytes, for example. Then we've got something that we haven't seen yet, and it's called the keychain. And this is an API that allows us to save, again, small bits of data inside a table, but allows us to save it securely. And Apple takes care of a lot of the heavy lifting of keeping the data that you put into the keychain secure. So this is for things like, usernames, passwords, things that you probably want to keep secure for the user. And then we cross the threshold and we move into the database solutions. And the first one that comes to mind is SQLite. So pretty much all of your iPhone apps, their backend or the database that stores the data on the device is mostly using SQLite. And SQLite has been around for a long time. If you're familiar with relational databases like MySQL or SQL, then you are probably familiar with SQLite. It's meant to be a lightweight, easy to use relational database that will help you to persist large amounts of data. And it has efficient ways built in order for you to query data from it. So for example, when you're trying to sort a SQLite database, you don't have to load up your entire database on your tiny iPhone and then try to sort everything inside. No, people have come up with really efficient solutions so that it's quick and it's not so intensive on memory. And if you're familiar already with the querying language and SQL databases, then this might potentially be a solution that you want to use. Now, the next one in the list is Core Data. And this can use SQLite as the database. And whenever people talk about core data, you'll hear them hesitate to call it a database. And the reason for that is because while you can use core data to work with a relational database, it's so much more than that. It allows you to convert these individual tables inside your database into objects that you can manipulate easily using code. It gives you efficient methods to query the database using a more natural language. It can also do a lot of things that you can't do with SQLite. For example, monitor for changes in the database, and a whole lot more. I could probably talk about core data by itself for 40 hours. So we're only going to be looking at the most fundamental things that you can do with core data, which is basically create, read, update, and destroy. And that's the base functionality that you'll need for pretty much any database you want to use. And we're going to look into all of them. Now, the last one in the list is something called Realm. And this is an open source framework that is a much faster and easier database solution than core data. And it's fast becoming one of the most popular ways of persisting data locally on device. So we're going to be looking into that as well. So when you're looking to save data from the user inside your apps and have it persist across, app updates or iOS updates, then you should consider maybe one of these 6 methods. So if you want to persist just a tiny amount of information, like a small key value pair, then consider something like user defaults. If you want to save a small amount of custom objects, then think about using Codable and encoding your data into a plist. If you want to save secure data like user passwords, then use something like Keychain. And if you have a large amount of data and you need to be able to query the data to pull out specific entries inside, then you want to think about one of the database solutions. If you already know about SQLite, or you already have data stored in a SQLite database, then you might want to use SQLite with a wrapper. If you're setting up your data from scratch, then core data might be a good solution. There's a lot of help online for core data. A lot of people use it. Most iOS developers are familiar with it. And finally, if you want to be able to do, I would say most things that you can do with core data, but faster, quicker, and have a more efficient database solution, then you might think about something like RAM. So let's get started looking at firstly core data and then looking at RAM, and you can make your own decisions when it comes to creating your own apps.